There we go. All right. Hi, everybody. Welcome back. Day 9, I believe. According to Google Lauren. We are doing 9.6, which is on the algebra of functions. There's a lot of stuff before we get to it, but this is your whole fog X thing that you may have seen before. We'll get to that. And 9.7 is on inverse functions. So algebra is adding and doing. Algebra involves doing arithmetic operations on variables. And on this case, we're going to do it on functions. And we have a very makes you want to slap the shit out of someone shorthand way of showing a lot of this stuff. So if we have two functions, f of x and g of x. Say we have f of x and g of x. If we want to do f of x plus g of x, there is a shorthand notation that says f plus g in parentheses and x in parentheses. And if we want to do subtraction, which is just basically opposite of addition, same shortcut, but with the new sign. In fact, this applies to all of our basic arithmetic operations. In this case, this is a dot for multiplication. Those are our shorthand forms of doing algebra functions. Now, I think I've told you guys that mathematicians are lazy fuckers before. I don't know that any of you believe me. Other than, well, looking at me and going, yeah, he looks like a lazy fucker. I'm very much a lazy fucker. But like, let's look at what they came up with. Have they saved us a lot of time and effort by coming up with this whole new notation? I still have an F. I still have a G. I still have a plus sign. I had this set of parentheses. I have this set of parentheses. I've got 1x. And that's what we saved. That's our saving. We saved it. By confusing the shit out of every student in this math field going through this shit, we saved ourselves having to write one fucking X. One X, one letter. That's what they felt the need for, like, you know what, this took too long to write, let's trim it down. And that's the best they could come up with. Right? You're right, it does take up less room horizontally on a page. I guess if you're trying to save paper back when paper was super expensive, that might have been a reason. I don't know how far back they did this. But they didn't save any time, they just made things more confusing. Okay, so let's look at a couple functions. Yeah. F of x is going to equal 3x squared plus x minus 14. And g of x is going to equal 3x plus 7. So let's say I wanted to find f plus g of 0. Which really means f plus g where x equals 0. Your job is to remember that this means f of x equals 0 plus g of x equals 0. And we have a couple ways of going about it. Option 1, find the two things individually and combine. So f of 0 means to take f and replace all my x's with zeros. And I get negative 14. When I do g of 0, I have 3 times 0 plus 7. So I get 7. So finally, if I want to find f of 0 plus g of 0, which is the f plus g of 0 that we had above, we're just adding these two together. Negative 14 plus 7 is negative 7. Everyone with me?
Yeah, for every x, place of 0.
Yeah, and because that's what it gave us. So if we wanted f plus g of 2, we'd have to do it all over again with 2. So that's where option 2 comes in. Option 2 is combine them first, then evaluate. So let's do that here. We want f plus g of x, which is f of x plus g of x, which is 3x squared plus x minus 14 plus 3x plus 7. And if I finish combining them, I get 3x squared plus 4x minus 7. Now, if I want f plus g is 0, it's just a quick plug-in. I can quickly do a whole bunch of them if I want. F plus g of 1 is 3 times 1 squared plus 4 times 1 minus 7 looks like 3 plus 4 is 7 minus 7 is 0. Interesting. I could do f plus g of 2. This is 3 times 4 is 12 plus 8 minus 7 is 13. I'm off screen. So option 1 is really only a good choice. If you need to evaluate for one value. If you may need a bunch. Numbers evaluated. Combine first. Let's put those back up. Why don't you guys try f minus g of x f times g of x and f divided by g of x. And we'll do them all together in a second. I want to give you guys a little practice getting used to reading this notation and rolling with it. Yeah, 2 more minutes and we'll do it together.
What is it, f of x and g of x equal 1, right? F of x is 1.
No, if x is 3x squared plus x minus 14. We're not plugging in any numbers or anything, we're just using the base forms.
Part of it.
So we do the -1. That's my f,
Yes,
and I'm gonna subtract my g.
you have to use the parentheses.
Well, if you don't, there's a good chance you're gonna fuck up the next step. Because the negative does have to hit both of those. That needs to turn into a -3x minus 7.
So, I forgot to use it.
And if you don't need the parentheses, if you jump straight to this correctly, you don't need the parentheses.
Oh, okay, right.
But a lot of times when students skip the parentheses, they get the -3x right, but they don't change the sign on the 7. Then when you finish combining like terms, there's 2 forms of x and -3x go together as -2x, and -14 minus 7 is -21. So that is f minus g of x. All right, so let's put a line there. This one's not going to be pleasant. I need to do multiplication. So this is my f of x. And my g of x is this. So that equals, if we start distributing, 3x squared times 3x is 9x cubed. 3x squared times 7 is 21x squared. Then I'll distribute the x. X times 3x is 3x squared. X times the 7 is plus 7x. Distribute the -14. -14 times 3 is -42x. And -14 times 7 is,
98,
yeah, 70, and 28 is 98.
80.
So if I combine like terms, looks like I got 2x squared terms that add up to 24. And I got 2x terms that add up to -35. And finally, do the division. So f of x goes on top. G of x goes on bottom. We should always try to simplify this. Is the top factor. Do we have two numbers that multiply to negative
Yes,
42 and add to 1? Yeah, it should be 7 and negative 6, right?
yes,
So I'm gonna do I'll do this down here. I'm gonna split that x, splits up into 7x minus 6x. We'll do some grouping here. Group those and those. Only an x comes out there. And if I want another 3x plus 7, I need minus 2. So the top factors to x minus 2 and 3x plus 7. The bottom is 3x plus 7. This does simplify. But it's gonna make something on the bottom go away. So we wanna find the domain restrictions first. Bottom can't equal 0. Which was g of x. G of x cannot equal 0. So 3x plus 7 cannot equal 0. And if you solve for x, you're gonna get negative 7/3. So f divided by g of x simplifies to what? Not to 1. What's left over after I cancel like terms?
-2.
Just x minus 2, right?
Oh, yeah, I meant the denominator equals.
Yeah, the denominator will be 1, yeah, definitely. And we're gonna say with x cannot equal negative 7/3.
Where'd you get the negative 42 from?
Negative. Where are we at?
Could we combine?
3 times negative 14, a times c. That is negative 42, right?
Yes.
Okay. All right, you guys ready for more?
No.
That's good, because we're doing them.
Oh, no, I mean, wait, hold on.
Oh. Need a little bit longer, okay. You guys have done this stuff before, we just didn't use f of x and g of x when we did it. We did rational expressions and simplifying them, and this was part of chapter R. You guys did this stuff, we just adding the f of x and g of x part. Now, if you didn't like it then, you're not gonna like it now, but. Couple other people are still writing, I'm gonna give you a chance. All right, the next concept is the fog x. Fog x is f with g of x put inside. So replace x in f of x with g of x. We'll do that here. I'll rewrite what f of x was. It was 3x squared plus x minus 14. G of x was 3x plus 7. So this notation actually doesn't save writing, it actually makes more writing. So if I want to do f, and we say f of g of x, that's how that is read. F of g of x. So we'll do that here. Everywhere I see x in the f of x, I am going to replace it with 3x plus 7. Ay, this is not going to be fun. Remember when we square, it means this. I can combine this information. 7 and negative 14 makes negative 7. And if I distribute, I get 9x squared. I get a 21x from this 2, and it's 21x from this 2. 21 is 42x. And 7 times 7 is 49. I still have my plus 3x minus 7. If I distribute, finally I can combine like terms. Not a lot of fun. That's just because we had to square 3x plus 7. That was well, and then multiply by 3, which was a little tedious.
In which scenarios would you put the brackets?
I can use parentheses there instead of brackets.
You're just filling like the brackets.
I tend to do brackets when I'm going parentheses times parentheses. I feel like if I do brackets, if I do parentheses, to start thinking it's the same parentheses, and if I do brackets, it's clear I'm like I've changed something. That's my methodology. All right, you try g of f of x, which we write as gof x. This is substantially easier.
So
except,
then we distribute the three. Divide by two.
and that would be it.
You get
Yeah, what is
39.
the 39x? Pretty sure it's just plus 3x.
I
Minus
fucking
three.
got all, I read that as 42x. That's just wrong.
Yeah, I think it's like 9x squared plus 3x minus 35.
That looks better. I'm just making shit up.
Is that a test?
I would like to claim that that was a test to see who was paying attention, but that was not. I make mistakes. I'm human. It's good that you're paying attention and caught it though. And said something is even better. Because I'm sure someone wrote that down and wasn't gonna question it, even though they're going, huh? A lot of students will look at her and assume he's the teacher, he knows what he's doing. And I do know what I'm doing, but I do make mistakes. Yeah, I get distracted. I'm thinking about the next fun part that goes along with this, which is the domains. So looking at domains of these, like what are the valid inputs? So like when you're doing all of the arithmetic ones, it's the overlap of the domains of f of x and g of x. With the exception with f divided by g also has g of x can't equal 0. Usually it's not a big deal. Usually it's all real numbers. For most things, it's all real numbers. The ones where you get hiccups are when we have tricky shit going on. And it's not even for those, it's not too bad. Again, it's just the overlap. So like if we have f of x equals 1 over x minus 3 and g of x equals square root of x plus 9. This one, we can't have the bottom equal to 0, which means x cannot equal 3. And square roots, the inside has to be non-negative, is the way to call it. It just really means greater than or equal to 0. So this says x has to be greater than or equal to -9. So if I did f of x plus g of x, which really doesn't do a whole lot when we add them together. Oops. Our domains have to overlap. So if I do a number line, my f of x is, no, it's not, that one's fine. Is anywhere but 3. So that's f of x. And g of x is greater than or equal to -9. So where these overlap, starts at -9, goes up to 3, f of x doesn't include 3, so neither does the combination. And does this. So we'd have -9 up to 3 in union with 3 to infinity. Now, where the real fuckery comes around. Maybe I should do the next page. And pause, make sure everyone's got this part written down.
Why does f of x continue in the negative direction? And we not report?
F of x, like if I plug in like -12.
Yeah.
-12 minus 3 on bottom is -15. I can have 1 over -15, that's a number. It's not a good number. So f of x does continue on, it's the red line. But g of x doesn't continue past -9. So I have to have the overlap. Like where do these things, where are they in common? They're in common right here. And nope, not at 3, but they're in common past it. So I'm looking for where they, like, if I laid them on top of each other, where would both lines be?
But where are they both true? Both.
Yeah, they both have to be true. All right, so let's look at the fuckery that comes along with our composition of functions. That's what f of g of x is called. Fog x is called composition of functions. The name's not important because I didn't say it earlier, so it clearly isn't that important. But the domain thing here is, domain is the overlap of g of x and f of g of x. So when here it's the domain here. When I stick g of x into f of x, this portion right here is really the range. So it's like the range of g of x in f of x. So what is the domain there? I think this is much easier to show with an example. And we will continue with the example we just had. We had f of x equaled 1 over x minus 3. And we had g of x was the square root of x plus 9. And we argued this had to be non-negative, so greater than or equal to 0. And we saw x was greater than or equal to -9. So like -9 to infinity. That's the domain of g of x. And I really don't care about f of x. I care about f of g of x. F of g of x is 1 over the square root of x plus 9 minus 3. And now here, the bottom can't equal 0. So I have x plus 9 minus 3 cannot equal 0. So we'll solve for it. X plus 9 can't equal 3. If I square both sides, I get x plus 9 can't equal 9. So x can't equal 0. Along with that, so our f of g of x domain, which is fog x, is it starts at -9. It goes all the way up to infinity, but it can't equal 0. So we stop at 0 and we do a union with 0 to infinity. Well, let's take a quick 5-minute break. Pause the recording. Let you guys use the rest. If it makes you feel better, I'm not going to test you on the domain of f of g of x. Because this just really doesn't pop up a whole lot anymore in all of your classes. And so it's not really like, this is like, well, if you want to be a mathematician, know this shit. But like if you're going to be like an engineer or something like that, you probably won't see this a whole lot. So I'm not so worried about testing it. In fact, if you look in our textbook, the John Blakely textbook, he doesn't even cover doing the domain. Because it's really like in big picture, not important, but I don't know what everyone's going to be when they grow up. So I at least want to introduce you to it so you see it. We're gonna do one more that's a little bit like trickier. F of x is the square root of x plus 3. G of x is square root of 2 minus x. And we're going to look at fog x again. So we start off with the domain of g of x. This, we've got to set the inside to be greater than or equal to 0. And I can subtract 2 from both sides. And if I divide by -1 or multiply by -1, it flips the inequality. So I'm going to have negative infinity going up to 2. Whoa, tricky. We had that fucking sign flip again. Now we stick this in and we got square root of 2 minus x plus 3. So this is our fog x. And we want that to be greater than or equal to 0. So I subtract 3 from both sides. And I get that. What should I do next?
Square both things.
Let's try it. We'll square both sides. And I get 2x, 2 minus x is greater than or equal to 9. So if I subtract 2, I've got negative x is greater than or equal to
So
7, and so x is less than or equal to negative 7. And when I combine with negative infinity to 2, the only of the overlap is just negative infinity and negative 7. If you look at a number line, this is x is less than or equal to 2, and this is x is less than or equal to negative 7. So the only overlap is right here. Guess what?
Oh, yeah, just.
That's not the domain.
what? Oh, it's wrong.
You would say we didn't do anything wrong, did we?
Well,
We didn't perform any operation that was incorrect. Look at the graph. It's 2 to negative infinity up to 2. So where did it go wrong? What did we do that? Like, why is there more to our domain than what shows? So this isn't it, believe it or not. We saw on Desmos that it was negative infinity to 2. Ooh. And the issue stemmed from here.
square.
We had square root of 2 minus x is greater than or equal to negative 3. Squaring both sides is a valid operation. But there is more of a restriction here than, like, of course it's greater than fucking negative 3, it's a positive number. Really, square root of 2 minus x is greater than or equal to 0. Which is greater than negative 3. So like, we can do better than negative 3, we can include higher numbers. And if we build off of this, square both sides there. We end up getting with our x is less than or equal to 2 again. And that's why we saw what we saw on Desmos. That's some tricky ass shit though, right? That required recognizing that there's some bullshit going on here. Right?
Yeah. So would there be a situation where we would square or no?
Well, we did square it.
Maybe you did square it, but I mean,
We just fixed it because this was insufficient. There was more values or,
we just didn't need.
right. All right, let me do this. I'm going to try to start separating the videos into sections, so I'll stop recording.